and things that depend on Kubernetes and depend on the release kind of be present in the external dependencies tab. So when we go towards release and go towards code freeze, we can kind of make sure that everything works. And if it doesn't work, who to contact and so forth. So I think the best way to do this is I'll send this out on SIG Network and then solicit responses via email, and then we can go from there.
Okay, sounds good to me. Thanks for putting that together, by the way. Okay, Casey, do you want to talk about the meeting?
Yeah, I'll try to be pretty quick. So SIG PM has reached out to us and has asked each of the SIGs to nominate a representative to attend some of their regular meetings. This representative would be a liaison between SIG Network and SIG PM and would include responsibilities basically tracking and identifying features that we're responsible for each release, and communicating that information bidirectionally, so attending both the SIG Network meetings and the SIG PM meetings. So I wanted to open it up to see if that was a responsibility that anybody on this call is interested in picking up. If that sounds appealing to somebody, there is an open slot.
If nobody else really wants to do it, I will volunteer, but it would be great if somebody else could as well.
Dan, if you volunteer as primary, I could nominate myself as secondary to share the load.
Okay, that could work.
Cool. Was that Dan and Christopher then?
Yep.
Cool. So I will mark that down as the first set of representatives, and we can potentially revisit in the future if that responsibility is too much.
All right, sounds good. Should we jump on to multi-network then? Also, I did start recording, by the way, just so everybody's aware. Okay, multi-networking. So obviously Joji has had a document out there for a while that's gotten a ton of review and questions. Tim took a look at that the other day and dumped a bunch of questions in as well, and there's been some conversation going back and forth on those things. Tim, at this point, and maybe Joji too, what do you guys see are the main outstanding issues? I can add a couple.
I have a list of 6 issues that I summarized based on the comments. Tim, please chime in as well. But I think the first issue is about overlapping IPs. So I think without touching services, we will not be able to allow overlapping IPs, because that will result in erroneous behavior with services, because you could have a service in a different network, a service endpoint in a different network, and a client trying to access it will get it'll get mapped to some IP address that's an overlapping IP, like a duplicate IP, and it could end up going to the wrong backend. So there are issues there that's not addressed at this point. So consistent with our plan to keep services out of this effort for now, I think we have to take the stand that overlapping IPs are not allowed.
So I think, if I may, Joji, I think the problems that we're looking at right now are a little higher level than that. Like, it's unclear after reading it and reading all the comments, it's unclear to me that we have shared agreement on what the actual objective is. We talked a little bit at DockerCon, but I get the sense that other people have very different goals for this. And as such, we can quibble about the details of the doc, all day, but I'm not sure that we're going to get anywhere, because I think we're all speaking in different languages.
Okay.
So I sent a note out today just like trying to get a sense of what are people actually hoping to achieve with this. And already the responses, the very few responses, thank you folks, have been sort of wildly different from each other.
I was going to send a response, but I didn't have too many besides your original 4, Tim. I thought all those 4 were more or less valid for us.
You said all 4 were valid?
Well, some of those we were interested in doing for OpenShift. Some of them we aren't necessarily going to pursue at this time. But
I was hoping that people would chime in and say, like, of the 4, which one or ones are most interesting to them, and if there's more than the 4 that I sort of described, that they would cover those extra details. So I would very much like to hear, like, OpenShift cares about number 3.
I would say that OpenShift cares more about 2 and 3. We currently are mostly doing number 1, but we'd like to move to more of a 2 or 3 model. 4, I don't think we are discussing on the OpenShift side quite yet, but who knows what the future holds. I hope that makes it a little bit clearer.
Some, but I feel a little bit like we've got a bit of a reboot going on here.
Hey, Tim, Michael Payne, and I know I work for a big enterprise. Some of you know who that is. You know, as we discussed in DockerCon, I don't think we would want to use multi-network in our cloud environment. So we've made a conscious choice to try and create a new environment following sort of more cloud-native principles. We don't want to get into different interfaces for different networks. We don't want to get into subnet and VLAN hell. It sort of feels to me like the multi-network is something that may fit in a legacy world, like you mentioned SAN, for example, or carving out separate networks. But that's something we don't want to do. We want to move that stuff into more of a network policy and handle that at layer 4 or 5 through 7 firewalls. So I think the complexity of multi-network is not something that we'd like to see.
So I guess I'd point out here that I have never necessarily thought of multi-network as restricted to subnets and that kind of thing necessarily. To me, it's always seemed like a little bit above that, more of a logical split that could be implemented via subnetting or could be implemented via filtering or that kind of thing. I guess I've never thought of it as, you know, specifically in the way that you were talking about it. That could be one component.
Which I think backs up Tim's comment that we're still having issues with terminology and understanding here.
Yeah, I mean, most of the conversation is around how do you map a network into which plugin it uses, right? And so, like, a filtered view, like, or some default policy application or something like that is a very different answer.
Right. Yes, this is Chris. You know, I don't. If you wanted to do, you know, I tend to agree with you, Tim, in the way this is being talked about. Because if you wanted to do multi-network as policy, you know, and render that as policy, that's something you could do today. So to me, this seems like it's much more about, you know, creating extra spigots and separating those in classical networking terms. And that's where I sort of have some of the same concerns other people have here.
So from my point of view, in my corner of IBM, I'm trying to decide whether I want to answer in favor of Tim's.
Mike, I don't know about anybody else, but I can't hear you almost at all.
Can you turn your gain up, Mike?
Oh, let's see if I can figure out how to do that.
Or speak very loudly.
Where's the control in Zoom for audio gain?
It would probably be in the OS audio gain area.
Okay. Oh my gosh. Oh, wow. Okay.
There we go. That's a lot better.
Okay. Okay. For my corner of IBM, I'm trying to decide whether I want to answer in terms of Tim's number 3 or number 4. I don't want to ask too much, of course. I'm thinking we can probably live with number 3. But yeah, I totally agree. We need to be, you know, agreeing in high-level terms of what we're talking about. And so I answered his question in terms of sort of user-facing functionality. I want to look at, we're talking about making a multi-tenant cloud. We want to have something like AWS VPC. So we got different tenants that have independent control over their address space, and no connection between them unless they take special steps to make some connection.
I think the only valid use case I see right now is use case number 1. I could probably live with number 3, but to me, it's not a good enough use case to introduce all of this complexity. Given the talk that we had on the proposal, it adds a ton of complexity to the user, and it doesn't simplify things. And to me, it loses a lot of the benefits that we have created with this simple Kubernetes networking model that's very simple to understand right now. So unless you have very clear use cases that drive the need for that, I'm not sure we should complicate things for the user.
Well, yeah, my use case is really multi-tenancy. That Kubernetes just didn't start there.
So one question I have is that number 3 and number 4 seems to be having a fair bit of overlap. Is it just myself having issues understanding the big difference between 3 and 4, or they're intentionally one of them is a subset of the other one?
So I wrote it, you're meaning my number 3 and 4, right?
Yes,
So
correct.
the difference that I saw was number 3 implicitly says a network is larger than namespaces, and number 4 says a network is smaller than namespaces.
I see.
This is the taxonomy that I was thinking of, right? Number 3 was sort of, I was thinking as the a tenant network. So say you're Coke and you get a Coke network, and all of your Coke stuff shares the Coke network, and that's it. And number 4 is I'm Coke and I want to create a Fubar network and a Barbat network and a Quux network, and I can then go do those things as an application level construct. That's the difference that I saw.
Yeah, I haven't seen a use case that requires that kind of granularity, the one that you're describing now. Where you need the network to be more granular than the namespace.
Do we need to perhaps make a distinction between networks that do need to be exposed to Kubernetes and networks that don't? For example, I'm thinking of the storage network case. On the storage network case, it seems very unlikely that you would care about having services on that network, or that Kubernetes would really need to know that much or care that much about getting packets into that network. I'm just wondering if that kind of distinction is a usable one to make or not.
Yeah, so that was going to be my second point, but we said we would just take a step back. So if you're ready to move on, then we can. But in general, talking about the complexity that this is going to introduce, I want to point out that all of this is going to be backwards comparable. This is not going to increase the complexity of any of the existing applications or any of the existing setups. So just to make extending what's available and addressing use cases such as storage networks and any such separate network use case. That's the whole idea.
I'm not sure that just saying it's backward compatible doesn't mean that it's not introducing complexity. So I think I kind of second Thomas's view around there's a real risk here that we introduce a bunch of complexity for some very valid use cases that some people are passionate about, but represent a very small percentage of consumers of the Kubernetes API, when probably most of those requirements could be met today with the existing API. So, and I don't claim they all can, because I don't think I understand them well enough. But I know, for example, there's multiple people have done a CNI plugin that can call onto other CNI plugins and connect multiple interfaces to a container without Kubernetes knowing about it. And the only concern I've heard with those is, well, they don't know which networks they're supposed to attach. Well, you could just use an annotation on the pod, and then you're done, and you've met that use case that you might have for, say, some pods need SRIOV, but we don't want to give them to everything. In a way that allows people who really care about that to leverage those more niche tools, but doesn't pollute general Kubernetes API for the kind of 95% consumer of the Kubernetes idioms.
Yeah. So with regards to that, so one quick comment with to both your comment, Alex, and to Tim's distinction between 3 and 4 in relationships with tenant versus networks. This might be a stupid question, but multi-network at what level? That means within a pod, or within what does multi-network within which scope? That would be my first question.
I think that's, Brian, I think that's actually one of the big distinctions. And this is the part that I think is just really unclear what people want right now. So very concretely, right, having tenant networks, what I call number 3, is much more akin to what AWS does or what GCP does with, you get a whole virtual network with your whole space and it's yours to subdivide, and if you want to traverse outside of your network, that's a special thing. And you go the other extreme, and like Docker with libnetwork lets you and sort of encourages application-specific networks where the application developer specifies the driver and the connectivity between the networks, and services map into which networks they're present in, and that is reflected in your DNS, and it's reflected in your routing, and it's reflected in your number of interfaces. And it's an incredibly complicated thing. It's very powerful, but it's incredibly complicated, and that's the part that I'm really scared about.
Yeah, so with regards to that, because that's exactly why I was leading into this, because we have a customer, actually a very large bank, that they they use a tenant in an OpenShift project, just like project should be. It's actually an OpenShift customers. And one of their use cases was that for some specific applications within a tenant, they need to be via special custom labels or third-party annotations or stuff like that, be attached to with customized networks. In their case, globally routable or connected to other parts of their infrastructure, right? And that's within a tenant. So in that sense, but that does not necessarily mean that a single pod would be attached to more than one. Again, that may or may not be the case. We haven't addressed that, but their clearly spelled case was that within a tenant, there may be different pods that via special annotation, they're attached to custom networks, which if that implies that within a tenant, there will be multiple networks with different characteristics attached to that. So that will be clearly mapped number 4.
Do we understand the source of that requirement? Is it regulation?
Yes.
And another.
So working for a large financial services organization that's heavily regulated. When someone says it's for regulation, ask which one, because it's often used as a very good excuse to put in a whole bunch of stuff that we shouldn't have.
Yeah. So regulation was one. So let me give you one thing, and I'll get back to you on that. But another concrete example was that there might be application that they need to connect to an Oracle rack that is space which is outside the network, the Kubernetes universe, and that has a specific subnet with no tenant that's attached to that's routed to that Oracle rack within ways that we may or may not know.
So this is Chris. I guess I'm having a little problem with that example right there. You said there may be, is this an actual?
They do have it.
And they are literally saying that everything has to be in the same subnet as the Oracle rack?
No, they need to be the applications that need to have access to that Oracle rack need to be in that specific subnet.
And that's because of legacy firewall issues, correct?
Yes.
Yeah, I mean, so again, Talking. Sorry, Chris. Just to explain exactly how we're doing that in our financial services organization. So we wouldn't put that stuff in the same subnet. In fact, we want them in different subnets and different networks. But the way we handle that is through some sort of external dependency broker, which is essentially a permissioned proxy that allows secure things running in the context of, say, a Kubernetes environment or a Mesos or some sort of container environment, and then have to be permissioned through that external dependency service. We're not going to allow plumbing of, say, Oracle RAC directly into those environments for security reasons.
Yeah, I think there's multiple ways. I've seen people solve that solution, that requirement other ways as well, and those are mechanisms that are available, as Alex said earlier, in the existing APIs. I really don't want to see us drop a whole bunch of complexity in here to handle use cases that we can solve other ways and that over time will probably be deprecated anyway. The assumption that a specific IP address has long-lived meaning in this world is hopefully rapidly coming to a close. If we can find some other way of meeting that requirement, Michael gave one, I've seen some others. How much extra complexity do we want to add for a corner use case that will get smaller and asymptotically approach zero over time? I'm really concerned that we'll end up paying that complexity tax for a very long time for a very small use case.
More important, I think what he said
usually does not happen that fast. As much as we want to deprecate everything that's 2 or 3 years ago, it's not happening. I mean, we can still see Windows 95 being deployed everywhere.
Joji, but there are other ways of solving this problem, right?
Yeah, slow down. Didn't he already say he doesn't need the containers to be on the same subnet as the Oracle RAC? So we're already not talking. That's already out of the discussion, right? He doesn't need the Oracle RAC. He doesn't need separate network interfaces or attachments to reach the Oracle RAC. He just needs to have some IP connectivity and his firewall set up right.
Hello, guys. Can you hear me?
Yes, we can hear you.
This is Kural from Intel. I already commented So I already commented one of the requirements we had that we have a containerized VNF, and we need this VNF application to be running in 2 containers in a pod, and each pod requires a different network. One is like a SRV network, and another one is a data plane, like a DPDK or something, and another one is a management plane, which we can use overlay network like Funnel Weave or any networks. So this is what our requirements. We have a pod which have like 2 or 3 containers which should be connected to 3 different networks. For example, we use SRV as one of the physical network for the control plane, so that we can able to send priority traffic in SRV and DPDK packages in data plane. So this is one of the requirements we are pushing forward for multiple network.
So one of the things I'd say with that is that, I mean, you can kind of already do that. I think the only question, there's 2 questions with that. The first one is, do those other networks, the specific hardware-based or SRIOV-based ones, do they need to be reflected through the Kubernetes API somehow for consumers? And also hardware scheduling. Because if you only have 8 SRIOV interfaces on a particular node, we
already achieving it using the node feature discovery. So in node feature discovery, we already have the SRIOV. So we already find which node has SRIOV, and it's not a problem for us actually.
Okay.
And the problem really what we are facing currently is we already achieved what I explained, that using Maltech CNI and SRIOV CNI and DPDK CNI, which we developed ourselves. But the problem which we're facing with Kubernetes, right, we can't expose these network as a services. For Kubernetes, it's just to know only one network. For example, if we use Maltech CNI, it just return one IP address. So it just knows only one services. For example, it just know funnel. So I can run only one services over there. If I want to run SRIV services, network services, I can't do it in current Kubernetes thing. Like it supports only one services because you have only one cluster IP address, and it never going to support multiple services actually.
So again, this relates to my earlier question. If we're discussing multi-network or are discussing multi-interface in a pod, to me there might be.
It's both. It's both.
Well,
they are closely related. So you can limit the scope to be narrow to just say multiple interfaces for a pod, or you can talk about having multiple networks. So they're closely related. I mean, essentially, if you have two interfaces on a pod, they have to be two different networks.
I think the answer, unfortunately, right now to this question is yes. The answer is yes. We're discussing all of those things.
Yeah.
I want to point out something. I hate to fall back on this old trope, but the way that Google works, we don't have a single Borg cluster that handles all of our work, and we do have needs for segregated work for reasons like regulation or for reasons like extra high security. And in those cases, we have separate clusters for those things.
Right. Yeah, but I think in the other more common use cases, there will be requirements to interwork with other things. They're not purely Kubernetes clustering. I think that's where some of these use cases stem from. And there are use cases where you have networking applications such as NFV, which clearly require multiple interfaces. And you require some sort of control network to manage those. So some of those use cases cannot be handled today using the existing Kubernetes networking.
Well, I mean, I'd point out that they can be handled today. It's just that you don't get reporting of the network details back to Kubernetes, right?
Yes, I mean, they cannot be managed through Kubernetes. You need a parallel or out-of-band mechanism to manage them. That is the biggest problem.
Yeah, I mean, I feel like that is the core of the issue that we're all talking about is, yes, we can do all these things. We can hack all these things into our single CNI plugin, but how much of this do we want to make available through the Kube API and make available through whatever management is built on top of Kube Control and all the other, applications that talk to the API server?
Right. So on that topic, let me ask a question. For the network function virtualization use case, is that really a matter of you're trying to implement some network plumbing that's really below the level of, say, Kubernetes services? Or do you actually need to be able to reflect that network functionality as Kubernetes services?
Ideally, yes. Go ahead.
Yeah, we want to reflect those network things as a Kubernetes services. That's what our requirement is. For example, network virtualization functions or deprecache, whatever it is.
My next question then is going to be, do you need to reflect all sides of it as a Kubernetes service? Or is it, for example, if you've got, say, a filtering function, do you need to only reflect one side of it as a service? And so you can get away with, telling Kubernetes about only one side of it.
Exactly getting this question, actually.
I couldn't quite hear you.
I'm not getting that one, actually.
Okay, so you're talking about you want to implement some network functions. You want virtualized network functions. So you want one pod that has multiple network connections.
Yes.
Does this pod need to implement a Kubernetes service on multiple of those connections, or does it only one of those connections need to be reflected as an endpoint or endpoints in Kubernetes services?
So I need a pod with 3 services, and all these 3 services are connected to 3 different networks.
So what is actually used?
About NFV, and I know all the terms that are being used, but honestly, I have very little understanding what we're talking about right now. It would definitely help to even, if you want to discuss this, to have some kind of document that describes this specific NFV use case. It's very complicated. That's what I'm getting. To me, it sounds like
it's already It's already explained that in the documentation by Peter Su, I think, from ZTE Mobiles. So he already explained it with the neat diagrams.
It's not the multi-network document. That's a different document, I guess.
I think it's
No,
at the bottom of the existing one. It's in the services impact section. There's additional inputs and background info.
On George's document, there is a list of use cases that he has put there to support why multi-networking is required. And then one of them has to do with NFV. So
yeah, go to page 9. Go to page 9, Thomas.
So with regards to NFV, I'm going to hop on a soapbox and I'll make it very, very brief. The current NFV models that the industry is pursuing were very much developed in a VM large, large multi-tenanted components that just replicated basically service provider kit. I'm not even convinced that that's the right way to offer an NFV type of service in a new cloud native kind of environment. If you have a microservices environment, is that even the right way of doing it? So, are we wrapping ourselves around an axle to try and bring over a model where that model may not even be the appropriate approach to take in a containerized world? If you want to keep that model, use it where it was designed for. If you want to do NFV in this world, maybe there's a different architecture. Just because we want to port a big legacy thing over into containers, I'm not sure that into a model like this, I'm not sure that's even how far back, how much legacy stuff do we want to support going forward in this environment is a question. It's not just for this, it's just in general. How much legacy tax do we want to pay?
I'm not sure I'd go quite that far with it. I think there's still a lot of applicability of the stuff that Kubernetes has to offer to some of those use cases. But a lot of those use cases are obviously not microservice use cases. They would depend more on the scheduling, on the orchestration, and the container management parts of Kubernetes as opposed to ingress, microservices, that kind of thing.
Agreed, but I guess it's even a question of how much do we want to how much complexity do you want to add for things that you might decide might be doable or efficiently in some other model in a Kubernetes world. But it's a point. I'm not saying it's we shouldn't do it because of that. It's something to think about though as we're.
I completely share that opinion. I think I looked through the diagrams, and to me, this looks like it's just porting a VM-based construct over to Kubernetes one-to-one. To me, that's not cloud native, and it does not make sense to bring in that kind of complexity to the good and clean model that we have built.
Thank you for being more blunt.
So I looked at page 9, and yeah, it's just redrawing a VM-oriented picture without explaining why you need it. So I think what Tim was asking for is what's the actual concrete example why you need it. For Chris, I'm not quite sure I understand the point of view here. I mean, if you want to say Kubernetes is only good for implementing microservices, you can say that, but I don't believe it. I don't think Kubernetes even believes it, right? So if I want to use Kubernetes to host not just microservices, but stateful sets and virtualized network functions, it needs to be able to do what those things need.
Agreed. I guess my point I'm making is I look at those diagrams and it looks like it's a direct port over versus someone thinking about, okay, how would I do this in a Kubernetes environment?
Right. So what will be into the actual example, not just redraw the pictures.
Yes. How would you do that today in a Kubernetes environment versus say an OpenStack environment?
But already
porting it over.
So,
but I think.
Go ahead.
But I think we have already solutions actually. So it's not like it's not that or it's not there. So the customers or the technology is not that improved that you can put a VNF whichever there in a VM to a container. People are already trying it, so it's not that it's not there or it's like abstract but the people are already trying out. That's why they are putting it there.
I agree. Actually, I kind of support what you're saying. I'm just saying to really make your argument, it's not enough to draw a blank picture with nothing but VMs and networks. We have to talk about a more concrete example, and I think once we actually talk about some, we'll see the need. So let's do about it. Okay, just propose a particular network function, and let's talk about whether there's a more cloud-native way to do it.
Yeah, I agree. In a sense, we've drawn an implementation and said that's a requirement. I agree with Mike that we should, if we can, step back and say, okay, what are we actually trying to achieve? Because we had the same discussions in the past around, we need VLANs for isolation, right? Because people assumed that was the only way you could do isolation, right? And then when you explained there's nothing magical about those bits in the packet that were the VLAN ID rather than the IP address, people started to grok that, then we were able to move to simpler, more flexible models that were more compatible with the general direction that cloud native is going on. And at the moment, I don't feel like I grok where these requirements are coming from well enough to be able to really kind of spot those links and suggest where there might be simplifications.
Yes. So only to that, and again, I'm sorry to bring in a wishy-washy somewhere in the middle, but I think pushing back on just forklifting stuff in the VM and dropping in Kubernetes and expecting, yes, make an implementation a requirement is the wrong thing to do, and we should absolutely push back on that. On the other hand, I think we're all in agreement that once we boil down to something that something that we agree that it's lacking, that it cannot be done or it can be done, is too cumbersome to be done with what we have today. That's something we should consider. So I think we should be somewhere in the middle, but completely plus one the requirements to have this far more thought through in terms of what exactly it's missing, or is very cumbersome to do what we have today rather than forklifting a diagram and dropping in here.
Is there a way to maybe bring this discussion down a little bit to a somewhat simpler level so that we can perhaps push it forward? And by that, I mean, can we separate the question of services out from some of the more basic parts of multiple networks per pod? And maybe just try to start from a position that more people can agree on? Or is our services intimately connected with some of this? I'm just trying to find a way to break this down into small, discrete chunks that we could potentially build up, and after each one, reevaluate where we're at and how it fits into the next part.
Yeah. So then to just plus one on that, that's exactly getting to the earlier comment, just splitting this into multiple interfaces per pod versus multiple networks per tenant, for example, or whatever, just zooming out of one of those cases and agreeing on one or two of them would be much more useful otherwise than just throwing everything in the bucket, because we'll be ending up moving in circles.
Yeah, one of the things I'm thinking of here is with the small discrete network use case, is there a way that we could implement a way that we could reduce the scope of the spec somewhat, skip services, say that for now, every pod has to be on a default network, and the services will only work on that default network, which is essentially how Kubernetes works now. But then you can add these other networks to the pod if you want for the storage case or whatever other case. And that would work for the NFV case, assuming you don't need services there.
I think that would be a way to simplify it. I'm not sure that it's a satisfying result for enough people to be the final design, but it might be an interesting place to discuss.
I think it's an interim and at least a proposal. I don't think it's satisfying for everyone, but at least it gets us a little bit further.
to me, it's like the base question is why. And if there is not a good enough why, I'm not understanding why we need any of the complexity at all. Like if we add something small in, then it makes sense to add the next small chunk at the next small chunk, and we end up with like OpenStack Neutron. And that's, to be honest, what I'm trying to avoid here is to repeat the mistakes that have been done in Neutron and just add lots of complexity because it kind of made sense, and eventually you end up with this hugely complex configurable thing that can do everything, but is very complex to understand and very complex to support.
And the vast and a good chunk of those features that were implemented actually never actually being used in anger in a real network, but you're still paying the complexity tax on it.
So can we talk about a particular network function that someone wants to virtualize and put in a pod?
Sure. What is it?
I was hoping that the proponents of that use case would name some. If no one else,
how about a vFirewall?
Very good. That was going to be my suggestion if no one else had something.
Just use that as a strategy.
I know that Peter White from Metaswitch was suggesting an SBC, which is similar.
I mean, at least for some of this stuff, you can imagine that it would require fairly high packet rates, and that's why a lot of the implementations would end up using SRIOV.
Yeah, but I think that you can do all that today.
You can do all that today
without API changes.
You can't do it. You can't do it as performant in a different architecture, and I guess like
no. I mean, I mean, people have written CNI plugins that can connect one interface to your main pod network and another interface for SRIOV,
sure.
And that exists today for those people that need it.
Right, I think the gaps
on its own justifies extension to the Kubernetes API. I don't think.
Yeah, I think the gaps there are though in the management, status, and scheduling parts. If we assume that
the scheduling part is being solved separately.
How so? You mean within the Kube API or by a separate plugin to the scheduler that's private to each implementation?
Somebody on the call earlier said what the exact mechanism was.
It's not feature discovery. Not feature discovery. It's a Kubernetes incubator project which is developed in Intel, I think. Not feature discovery, which help you to identify the the network resources or resources in the nodes to discover the things and put them as labels. And using those labels, you can make the pod to sit in a particular node. So that's how we are implementing both SRIOV and DPDK currently in our setup.
Does that, you said put it on a particular node, or does that mean any node with that particular feature or a single node?
If you have like 3 nodes and you don't know in which node the SRIOV support is there, the node feature discovery will help you to find the SRIOV node, and using those labels as for example, if you want you have to just mention SRIOV equal to true, and then the particular pod will sit in the particular node which has only the SRIOV feature. Something like that.
There was another way of doing it. Somebody was discussing at the face-to-face SIG meeting was it just before KubeCon where we all met? And I forget what that mechanism was, but that was more rather than just labels and true and false. That was more about actually counting resources as well.
Right. We need to. Some of us at least need to count local resources.
Yeah. So I think there's people working on that, and that does to me feel like something that you can't just work around with the annotations, and does need to be part of the Kubernetes API. But I'm not an expert on the scheduling, so I'll caveat everything I said there with that.
That work is in flight, and in fact, my next meeting is on that topic. But the counted integer resources is going to happen. It's just slow because it's sort of complicated.
You can also use opaque integer resources in order for identify number of SRIOV, how many SRIOV virtual functions are available and how many are not there. So this is something you can find it in Node Feature Discovery project.
So we have about 5 minutes left. What's the follow-up to this? What I don't want to do is let this sit for another 6 months.
Yep. Well, it seems that the scheduling part of this is more or less solved. How about management and status parts of it? Is that
Yeah, can we identify all the pieces of the API that are missing to make this happen outside of Kubernetes and then try to address those?
I'm confused now which this we're talking about.
Yeah, me too.
So my thought with this is the simpler network use case where you want to put, say, like an SRIRV interface or a storage network interface into a pod, and it does not need services. Does that make sense, Mike?
So extra interfaces.
Yeah, I mean, I feel like that's the simplest case.
So you're talking about a generic feature. We're not talking about needs in applications. We're talking about a generic feature design that says we can request multiple attachments on a pod, and the pod reports just one into Kubernetes, which is the one that Kubernetes puts into service endpoints.
Well, I mean, currently this can happen today. I think the gap here is Kubernetes is not aware of any of these other things, so you cannot manipulate them through the Kube API. And the quick question for me is it worth doing this through the Kube API? I guess I tend to think yes, but it seems like there's some pushback on some of those ideas.
So I think we were on the important topic here, which is, do we have use cases that need more than we've got now, right? I've got one use case that maps, I think, to Tim's number 3, which is coming from a different direction, this network function virtualization. Maybe we can finish that conversation and have someone write up, for example, how to do the soft firewall with the existing Kubernetes, or why it can't be.
I would say it can be done with the existing Kubernetes. You just have to write a whole bunch of other tooling outside of Kubernetes to manage all that kind of stuff. And so, you know, it works out worse for plugin authors and worse for users because they have to deal with two separate, completely different sets of tooling to get what they want done.
There's always going to be things that Kubernetes can't express that fall sort of above or below the bounds, in as much as they're defined, which they're not. But there's always things that are going to be below, right? We don't handle creation of nodes, for example. So the question is, you know, can we find something that is sufficiently neutral that lets us carry it in band, or do we have to push it out of band?
Yeah, and I mean, I guess I thought a very generic, abstract notion of network that essentially just represents a logical network that the plugin over here somehow knows to hook up was going to be that general abstraction that we could all sort of get behind, but it seems like there may be disagreement on that.
I mean, even within the CNI space, like, it's complicated because the CNI layout is complicated, and IPAM could be before or after the primary plugin, and there's the chains that are coming, and Casey was just responded earlier today saying, you know, chains are going to become even more important in CNI, and I'm not sure what that means, but you know, like, I'm worried that whatever we describe here eventually devolves into a arbitrary JSON structure.
So when you say chain, just think of network, and the exact term that CNI currently speaks of networks.
May I just ask for some clarification here? I think there's two things we are discussing. One is to have a multiple, whether to have or not, multiple interfaces for a single pod. And the other one is the abstraction that Dan is talking about, which is the logical network. So no matter we have the logical network or not, having multiple IP addresses assigned to a pod can still be beneficial for a number of applications, such as the NFV that we're discussing. Just wanted to see if we all agree on this or not.
Yeah, I don't think that's controversial, and maybe that's a good way to take something off the table, would be to try to get that specified so that CNI can't, I mean, the CNI work is being done, right? So
it's already done, it got merged.
So, you know, finding a way to plumb that back into Kubernetes and express it all the way out through the API, just to say, look, we don't know how they got there, but there are multiple IP addresses.
Yeah, I think that would be great, but I think when you start having multiple IP addresses, if a plugin does report those because it created one or more logical or physical networks into the pod, it seems like a shame to not differentiate those in the API.
Yeah, I mean,
because then the users can't do anything with
you
it.
don't know what to do with them because now you've just got an unmakeable choice.
I'm not sure I understand. I mean, if CNI can return information about those, does that make a difference? Like, what is information? Flags, a name?
The way that I think we were looking at it was that each quote-unquote network would be a different CNI invocation. And so each one of those would be able to return information from that particular invocation.
Yeah, but I thought the problem you're referring to is if Kubernetes just records a list of IP addresses for a pod, then the consumer of that pod doesn't know which one to use for what.
Correct.
We need the ability for the CNI plugin to return a clue. We don't need to have, I don't think we have to, I don't think we can at the moment standardize what the clues mean, but we have to have a space where a clue can be.
Well, and I was thinking that clue would just be the name of the logical network, because if each logical network was a CNI invocation, you already have a delineation of this thing caused this IP address to be returned.
Yeah, I think that's tying two things together that are quite separate. Right? One is what am I using this for, and the other is what made it.
Yes, that's correct.
Yeah. I think from the consumer's point of view, he doesn't really care where they came from, or he doesn't. We don't want consumers to have to know how these things are made or where they come from.
Right. I think it would be interesting for the administrator, but not so interesting for the actual cluster user. So where does that leave us? I think to your point, Tim, yeah, that would be great. And maybe that is a great base to start from, is just to make sure that Kubernetes can report multiple IP addresses from even a single plugin invocation like we currently have right now. But to Mike's point, we do need to figure out some way of saying how those IP addresses are important for different things. Otherwise, there's no point in reporting 2 or 3 because you have no idea what to do with them.
I acknowledge that. I think the most practical short-term thing that people can do is respond to the "what are you trying to do with it" thread. The more concrete people can get, the more we can ask questions to try to get to the root of things and try to think through what currently exists and what needs to exist to satisfy these things. I would also, I guess, like to extend it to say, like, tell me how you're working around today. Like Mike Spreitzer, I'd love to hear more about exactly how you're working around the lack of this today.
Yeah, and I was going to say that, you know, if it turns out that half the people on this call, like you're saying, Tim, are working around this particular feature, even if it's not something that we would necessarily expect Kubernetes to do, is it worth trying to find out how to accommodate that because enough people are trying to do it? I mean, the answer to that may be no, Kubernetes isn't meant to work that way, so keep doing how you're doing it, hacking around it.
I have to admit that I'm only making plans. I haven't got much accomplished, but I'll be happy to outline the plans that I've got so far for coping with if things stay the way they are. Okay, great. I would love to hear your creative plans because, you know, sometimes a good workaround is just good enough. But I'm certainly sensitive to the fact that if lots and lots of people are trying to solve the same problem, like, you know, maybe there's something real there. But I also want to be really careful that we don't slip into this is what we know how to ask for, so that's what we're asking for.
Right. And that sounds good to me. I can certainly add some of our use cases and workarounds as well.
It's Michael here. I don't know whether this is relevant or should be taken into consideration, but as people are filling in that information, it may be interesting to know, is the use case like an R&D effort that is supporting just purely R&D and sort of is not a typical enterprise deployment, or is it an enterprise deployment, or is it something that a vendor is trying to work on for their product? Again, not sure if that's important. It is to me, but it may help in terms of assessing the use cases.
So did you want those replies via email, Tim? on the
I
list?
mean, I think email to the group is great because we can collectively ask follow-up questions and try to get to the real kernels of the functionality that people are trying to go for. Since it's very clear to me that we're not in agreement, and after an hour, we're still not. So.
And just to be clear, that would be replies to the what are people hoping to do with multi-network thread, right?
Correct.
Okay.
Just to clarify, then we are supposed to reply to the thread that Tim just started to list our use cases. It's not going
Yeah,
to
I mean,
document for that, right?
unfortunately, the design doc is very complete, which makes it actually really hard to debate at a high level because there's so much detail in there that, you know, it's sort of like taking a step back to like, can we crystallize some of the basic behaviors requirements?
And then after we get enough discussion there, we can obviously pull out the common parts of those use cases and stuff them into the doc or even a new doc or something like that.
Of course. This is not this is not trying to wipe away the doc.
Yep.
It's trying to get to the skeleton through all.
All right. We seem to be at time, so hopefully that's good enough for most people. Hi, Mike's dog. All right, sounds good. So we are going to have
that'll be working for me.
Okay. We are going to have a meeting next week. Is that right, Tim?
You know, we have enough to talk about. I wouldn't mind a meeting next week.
Yeah, I mean, I think next week is a regularly scheduled meeting, so I think it's on the calendar.
It should be, yes. I see it. Just making sure.
Okay. Yeah, I think we are meeting next week then.
Okay.
All right.
Ready next week then.
Cool.
Thanks, everybody.
Thanks,
Bye-bye.
everyone.
Cheers.
Conversation. I appreciate it.